Okay, so this is a video on surds. It's on multiplying, dividing, and a thing called rationalizing the denominator. Well, hopefully this time I've worked out what the heck was happening with the screen, and hopefully we can see it just fine. Okay, so let's get straight on to multiplying surds. Alright, here's an example of a surd root 18, and we recognize from the last video that we're allowed to take that number and we're allowed to split it into two because they're the factors of 18, and you'll remember that what we're allowed to do is then split it further, completely split it into two separate entities, and then we can find that if it can square root, say for instance this one here can square root, we would square root that and show that was 3 times root 2. Well, multiplying surds uses that basic idea that surds can be split, and reverses the process and takes surds that are split and puts them back together. So this one that is root 3 times root 2 just becomes root 3 times 2, which is root 6. Now let's look at some variations on that idea. Here we have root 5 times root 15. Now the temptation is just to go 5 times 15, which is whatever the heck that is, 75, and to then simplify that root 75, and you'll see that root 75 is 25 times 3, and that square root 25 will simplify to 5 outside of root 3. Now let's have a look at an alternate way of doing that. Here we have the same question, but what I'm going to do before I do anything else is I'm going to split this up first. So it becomes root 5 times, come on, root 5 times root 5 times 3. Now we can see that root 5 times root 5 is there, which we know will make root 25, and we can take a shortcut and say that root 5 times root 5 will just make the number 5 times 3. And we see we get the same answer as we had one page earlier, and the process is a little different. We do the simplification, but why is this a better process? Well, let's have a look at a bigger, nastier kind of square root multiplication or surd multiplication. The temptation is often to just grab your calculator, and which I will, and go 18 times 42. And we get this number 756, so square root 756. But if we then wanted to simplify this big number, we'd have to go on a fairly big hunt to look for the squared numbers hiding in there. Instead of doing that, let's have a look at splitting 18 into its prime factors. And we would get 2 times 9. And then we can come across here and go 42. That's not a prime factor, that's a square. But we know that will simplify to 3. And then we'll come across this 42, and we might go 2 times 3 times 7. Well, looking across, we've got a 2 here, we've got a 9, which is a squared number, and we've got a 2 here. What does that mean? It means this 9 here can just come straight out and become a 3. It means this, I'll do this in green, this 2 times 2, which is going to make a 4, can come straight out as, or square root 4, can come straight out as a 2. And whatever's left over gets left on the inside, and that's a 3 times 7, which is root 21, which cannot simplify. So by splitting these up, we can see the factors hiding inside of it. And we can see if there's the same factor here, come on, there's the same factor here and in the other one, we put them straight together and pull them out and square root the answer. So 2 times 2 would be 4, we square root it straight away. And it means instead of dealing with this really huge number, we take out the squared numbers before we multiply together, and we can see our answer a lot more clearly, a lot more easily, becomes 6 root 21. Okay, so let's move along. This is dividing surds. Now the core idea here comes back to the idea of simplifying fractions actually. So any fraction that is, say, 21 on 21 is just 1. This is a core idea. If I had A on A, that would also be 1. We don't know what A is, but if it's the same on the top as on the bottom, then it cancels down to 1. If I had root 5 divided by root 5, again, that would be just 1. And why is that important? Well, let's have a look at our first question here. Root 3 on root 18 is the same as root 3 on root 9 times root 2. Oh, sorry, I stuffed that up. I don't have time to remake the whole video, so I'm just going to change this one. Sorry about that. Yeah. Alright, so let's say root 3 times divided by root 6. That will be a lot easier for us to see what I'm trying to show you. Okay, so root 3, terribly sorry, on root 6 is the same as root 3 on root 2 times root 3. And here we have here that root 3 on root 3. And that will just cancel. So a lot of what we're doing when we're dividing surds is we're looking to try and make a 1, I guess, and then cancel that 1 out. So on the top I'd have a 1, on the bottom I'd have a root 2. And we've simplified that surd in a division formation. Let's go to the next one. There's a rule, just like there is in the multiplication of surds, where if you've got a radical that is enclosing a fraction, we can split that into root 5. We can split that radical into a radical on the top and a radical underneath. And sometimes that means we can simplify our surds once it's been split from one big surd into 2 little surds. Alright, well, let's have a look at that in action. Okay, so ignore that title, Rationalizing Denominator. That's actually where we're going to go to next. Root 16 on root 3. Why did I write Rationalizing Denominator there? Okay, that becomes 4 on root 3. Here's why. Notice we've got underneath now. We've got a surd on the bottom of a fraction. What we call that is we say that that is an irrational denominator. Why? Because surds are irrational. We talked about that in the first video, and if you'd like me to clarify that, just let me know. But usually in mathematics we don't leave a surd on the bottom of a fraction. So what I'm going to do is I'm going to multiply it by an ugly looking 1. This thing here is worth 1. This thing here is worth 1. But when I multiply it across by my fraction, I get 4 root 3 on the top. Oh dear, 4. How about I rub that out and do that properly? You going to rub out? Yes, it is. I get 4 root 3 on the top because I just multiply straight across. But underneath I get root 3 times root 3, which would make root 9, which is just 3. Now mathematically, this answer here was correct. We did simplify the top. We couldn't simplify the bottom. But because this bottom is known as irrational, I multiply it by an ugly looking 1. And that doesn't change the value of the answer. It is still worth the same as this answer, but it's now got a rational denominator. Alright, let's look at this next one. I don't believe this next one will need to have its denominator rationalized. Let's have a look at it. We can see root 6 is the same as root 3 times root 2, and that's all on root 2. That can cancel, leaving root 3 on 1, or just root 3. Okay, let's go to the next page and see what's hiding on there. Here's a trickier one. There's nothing that can divide evenly, but this might be what you get after you've simplified a fraction. We've got a denominator which is a surd. We need to rationalize the denominator. How do I do that? I just want to get rid of the surd part of this, so I'm going to multiply it by a 1 that looks like this, root 5 on root 5. Now on the top, that's going to give me 2 root 10. On the bottom, I've got three lots of root 5 times root 5. Now we know that root 5 times root 5 is root 25, and root 25 is 5, so I've got 3 lots of 5, which is 15. And I can't take this any further. And that's it. Okay, so just to recap, we've got the skills of multiplying surds, dividing surds, and that tricky thing at the end, rationalizing a denominator. If you have any questions, just feel free to send me an email. There's a lovely exercise on this on MathSpace. Okay, thanks. Bye.